Hello everyone, today we're gonna configure single home BGP. Imagine up until now you've used a simple static route to get to the internet, but the business is growing. You've just purchased a public IP from your ISP and static route isn't just cutting it anymore. I wrote down our scenario here and the task. We have to establish a BGP neighbor relationship between our office, which is this side here, this network, and the ISP. We have to advertise the public IP that we bought from the ISP using the discard route as well. We need to receive and verify the BGP injected default route, and we also need to perform a route redistribution to share the path with the internal EIGRP routers, so we do not have to configure one by one here. Before we start configuring BGP, let's discuss the topology really briefly here. On this side here, we've got our network, which is using 192.168.100/24, and then on the ISP side, we have 185.3240.200/30. The loopbacks on our ISP is our internet, and we have EIGRP configured on our R1, R2, and R3. If we go into our R1 here, if you downloaded the files by the way, and you just importing the EVENG file, all the passwords are Cisco. Go to enable, password is Cisco again. So in R1, I'm just going to show you that we have EIGRP configured here. So show IP route EIGRP. As you can see, all the loopbacks in here are advertised. We got 192.168.10.20.30.40 and .50. And then I'll just show you from R3 that we can ping one of R2's loopback, but it cannot ping the ISP's loopback, since obviously we just want the EIGRP in our private network, and we're going to configure BGP later. We are on R3 here. I'm just gonna ping one of R2's loopbacks. So ping, let's choose loopback 0, 192.168.40.1. And then just to make sure that we do not have connection to ISP, we're gonna ping 50.0.0.1. And there you go. We cannot ping ISP for now. We also have a default route on our R1, which is pointing to the ISP. So that means our R1 can ping our ISP. So if I do a show IP static, show IP route static, you can see we have a default route, and then we're using the next hop as a gig 01 interface of R1. Back to our scenario, up until now we've used a simple static route, but the business is growing, so we bought a public IP from our ISP. Also on R1 we have NAT configured, so if we do a show run, you will see this is our public IP. You can see that we have a pool name called public pool 185, translating basically using this IP that we bought from our ISP, 185.3240.80/29, and then we have the configuration here, IP NAT inside source list, and the list number is 10, the pool, public pool, which is from here, and then we're using overload here because we want to use PAT as well. Okay, to check that our NAT is working here, we'll just do an extended ping. We want to ping one of the loopbacks of ISP. We'll use, in this case, we'll use 500.1/24, and I want the source of that ping to be this network here, 192.168.100.1. Because obviously if we do not do an extended ping, our R1 will use .202 here. So if we just do an extended ping here, so ping 50.0.0.1, our source 192.168.100.1. Okay, that just shows that our NAT is working. It means if we do a show IP NAT translation, it shows here that our inside local, which is 192.168.100.1 using this port here, has been translated to the public IP that we got from ISP, which is the 185.32.40.81. Since this lab is regarding BGP, we have to remove the static route from R1 to ISP, since we are an amazing network engineers and we want to use BGP now. So if we do a show IP route here on R1, you can see the static route here, which is the ESC and the star. So we just need to remove that one. So the command for that is conf t no IP route. Then the subnet mask is gig 00, obviously. There you go. If you do show run again, just to make sure that it's gone. Okay, IP route. There you go. The static route to our ISP is not showing anymore. And if we ping 50.0.0.1, it should not be able to ping the loopback 0 of the ISP. Okay, so in our topology here, only R1 is connected to the ISP, right? So that's the one we'll configure with BGP. Since these two will form the neighbor agency, in BGP we need to specify the autonomous system number. In the real world, in our case, we got 10 and 20, but in the real world, the AS is provided by the ISP. But again, in our scenario, let's say our ISP told us they'll be using AS20 and that we have to use AS10. We'll go back to our R1 again here. A command to configure BGP is router BGP and the AS number. Again, the ISP told us that we have to use 10, so we're going to use AS10. And then neighbor always confuses me because it's American. On our topology here, our neighbor to ISP, the connection connected to the ISP. So in our rack, this is our router, this is the cable, and this one, the IP address connected to the ISP's router is 201, so the neighbor is 185.32.40. 201, and then remote AS and the AS number of the ISP. So our scenario again, the AS said that they'll be using 20, so in this case we'll use 20, then we exit. I've just done a show IP BGP summary here. You will see the neighbor, which is 185.32.40.201, which is this one on the ISP side. The AS, which is the ISP's AS. The message received and message sent is 0 because we haven't yet configured the ISP side. So it's still trying to establish the neighbor adjacency. On the state and prefix, it's showing idle. Later on, you will see this change to prefix, meaning how many network advertisements have we received from this neighbor. Now we'll go to the ISP. Password is Cisco. Enable, password again is Cisco. On the ISP side, we use router BGP, the AS number 20. And then command is neighbor 185.32.40.202. 185.30.202, obviously we use 202 here because we're on the ISP router. The neighbor of the ISP is R1, which is connected to 202. And then remote AS, and what is the AS number of our network? It will be AS10. If we exit here, if we do a show IP BGP summary on our ISP, you can see the neighbor here is 185.32, which is this one. The AS number of that neighbor is 10, message received 4, message sent 4, and then I've told you before that this has changed because they have formed a neighbor adjacency already. If we go back to R1, before it was state prefix idle, now it's just states prefix and the value is 0. If we run this show IP BGP command again, you can see the neighbor of R1, the AS number of the ISP, and then here it doesn't show idle anymore, like unlike previously. Now it has a value of 0. There are two steps to configure BGP. It's not just these two commands. If you do a show IP BGP, it's gonna show nothing. Show IP BGP, it shows nothing. We won't see anything here because we haven't advertised anything. We haven't advertised a network. Let's go back to our router 1 here and let's start advertising our network. There are 2 steps in configuring BGP. If we run the command show IP BGP, you're not going to see anything, right? I mean, we just shouldn't anyway. So the R1 shows nothing. On ISP side, show IP BGP, there's nothing. Why? Because you won't see anything here because we haven't advertised a network yet. So in BGP, we have to advertise a network, but which one are we going to advertise? Are we going to advertise our private network? No, because we cannot advertise our private network to BGP because it's not allowed. The private networks are blocked by ISPs anyway, so it's just gonna drop all the packets. So what are we gonna advertise? We're gonna advertise the IPs that we paid for from the ISP, which is 185.32/29. Again, we cannot advertise our EIGRP network, our private network. We have to advertise the public IP that we got from the ISP. We're gonna go back to R1 here. The syntax is router conf t router BGP 10. We are on R1 here, so obviously we use the AS10, and the command is network 185.32.40.80. If we do question mark, it will be mask, and then the subnet mask of /29 is 255.255.248. If we do a show IP route here, is it gonna show in our right routing table? No. Let's try show IP BGP. Nothing still. Show run section BGP. Why is it that when we run show IP BGP it's not showing, even though we've already advertised the public IP that we got from ISP? But if we do a show run section BGP, it shows here that we've actually, I mean, we've done it before. You just wrote it down. Why is it? Because in BGP, it will only advertise the networks whose exact prefix and subnet mask appears in the routing table. So can you see, are we able to see this network here with the subnet mask /29? Are we able to see it here? No, the network command does not function like the network command in OSPF or EIGRP. If the router does not find the exact match in the routing table, it will refuse to originate that route into the BGP table. Meaning, it will only advertise if it sees this exact one here, this exact IP in the routing table. Again, if we do show IP route, as you can see, it's not there at all. That's why on the other task here, the second task, we have to advertise the public IP using the discard route. Let's now create our discard route. So we need to force the router to put that route in our routing table. The command for this is IP route 185.32.40.80. 255.255.255.248, and then 0, 0. If we do a show IP route, you'll be able to see our discard route here pointing to 0, 0. If we run show IP BGP, is it gonna show now? Yes, there you go. Since we've already satisfied the BGP condition, that's why it's showing here now. There. Then the next hop means if you configure this yourself, the next hop will always show 0.0.0.0. This value is always fixed. This one is not very important for the ccna. And then path I means it's internal. So meaning R1, our router here, R1 is advertising this network 185.32.40.80/29 internally. Later you'll see when the ISP is advertising something else, it will not show I here. We'll go to RSP router. Now we are on the ISP router. If we do a show IP route, has it received the BGP advertisement from our R1? We can only see CLC. We can see it here. We can only see a static route. If we do show IP BGP, we can see that there's a path to this network here, but there's an R beside it. It should have a star beside it. Why does it show R? If we just check one of these status codes here, it's showing that we have a rib failure, right? Because that network is already inside our routing table. Remember when I was explaining our topology, we had a static route configured, right? Obviously the best path for the ISP to R1 is a static route. That's why it's in the routing table. Routers always prefers IGP routes compared to BGP. So if we remove this static route, you will then see, I mean, obviously it only has the BGP as the best path, so it will replace the static route. So let's remove the static route that I've configured here. So it's it's using the next hop IP. So conf t no IP route 185.32.40.80. Next hop. IP route. As you can see, previously we had a static route for this network, but now since we removed that route, it has been replaced by the BGP we advertise. If we do a show IP BGP, it will show us that it's not having a rib failure anymore, and now it has a star sign, meaning that path is valid. The network here is 185.32.40. The next hop is the R1. Again, as mentioned previously, if we configure this ourselves, it will be 000. But since it received this advertisement from R1, it will say next hop 185.32.40.202. And then the path is 10 and it's internally. I just want to quickly touch on the path here is 10. That's the AS path. So that just shows the AS path that the ISP needs to travel or hop into to reach this network address. Let's say our public IP is here and we have AS10 here, AS20, AS30, the path will show 10, 20, 30, and then I. Now we're on R1 here. Since the 185 network is on R1's routing table, can we ping from R1 using the 185 network? So to test this, we'll do an extended ping using R1's gig 00 dot 1. Let's do a ping 50.00.1 source 192.168.100.1. This just shows we're pinging the internet 50.00.1, and I want the source to be this one here. Okay, let's try that again. No ping at all. We advertise our public network, right? But how come there is no ping? Because in a normal scenario, we would configure a default route. I mean, we always need to have a default route, right? We need to tell the router, hey, send all these packets that isn't in the routing table to the ISP. But since we can't configure a default route in this scenario, how will this work? We can't configure a default route. How are we going to tell the packets where to go? The default route will be advertised to us via BGP from our ISP. So the ISP adds a specific configuration, later on we'll do this, to their router to inject a default route into our BGP session. We normally prefer this method because if the BGP dies, the default route disappears from the routing table, and then the router stops trying to send internet traffic. Which means if we actually had a backup link here, it would allow a failover to happen instantly. Let's go back to our ISP here. Let's configure the default route. So router BGP 20 router BGP 20 network 000, mask is 000. If you remember, we need to create a discard route to force the router to put this in the routing table, or else we're gonna have another error later on. We exit on this one, IP route 000, and then null 0. If we do show IP BGP, you can see the network here, the next hop. Remember, we configured this ourselves. Again, this is a fixed value, that's why it's showing 000. Metric, local preference, wait, path is I. Now I'm in R1, I've just run show IP route. As you can see, we get a BGP here with a star or asterisk. You can see the default route here. The administrative distance 20, this one we're not gonna touch it. You can see B star here and not S star because it received this from a BGP update from our BGP neighbor. So if we run a show IP BGP, you can see both routes here, and then both routes are valid. If we do our extended ping again, we ping 50.00.1, the source is 192.168.100.1, which is this one. We should be able to ping now. Great. If we try 60.00.1, that should be good. If we do 70.000.1, that should also work. If we do show IP NAT trans, you can see that it's from our inside 192.168.100.1, the ports, and then it translated it to the public IPs that we receive from our ISP. Good, that all works, right? But can our R2 routers or R3 routers ping the internet? So let's go to our R2 here. Since this is already, okay, the password is Cisco. Oh, let's just go to R3 here. We'll do a ping 50.0.0.1. And then we'll go, how come we can't ping from R2 here? Let's wait for this one, enable, so it's Cisco, ping 50.0.0.1. As you can see, R2 or R3 cannot ping 50.0.0.1 because if we do a show IP route, R2 50.0.0.1 is not on R2's routing table. Is it on R3's routing table? It's not showing on R2 or R3 because R3 and R2, they also need a default route. Obviously, it needs to forward the packets that it doesn't know to R1. But we do not have a default route configurator. We do not have a default route configurator. So where are they going to send the packet that they want to send to 50.0.0.1? We can configure a default route here. We can configure a default route here. But what if you have 50 routers there? Are you going to console to each router and configure a default route? Obviously not, because that's very time consuming. What we can do here is we can configure R1 to advertise the default route and propagate that default route to R2 and R3. Remember when I was explaining the topology, we have EIGRP running in our enterprise network. We can use R1 to advertise at the default route that it received from the ISP through BGP into EIGRP. I've just found this out, but this is actually not included in the ccna's scope, but we'll use something called route redistribution, meaning we will convert one routing protocol, in our case BGP, to another protocol, in our case EIGRP. I'm not gonna try to explain this because I don't really know much about it, but I'll just go to R1 and configure the route redistribution. So if we conf t, the syntax is route EIGRP 10, and then the command router EIGRP 10 redistribute BGP 10 metric 1544. I spelled metric here. All of these has meaning. I'm not sure if you remember from your lessons, whoever is teaching you for the CCNA, this is the metric for EIGRP. This is the bandwidth, the delay, reliability, the load, and the MTU. If we actually just go back here, we distribute BGP 10, then question mark, metric, question mark, see the bandwidth there, we put 1544, and then delay 1000 milliseconds, and reliability 244, question mark, loading is 1, and then MTU we just selected 1500. So I'm not gonna press enter since we've already done it before, and then that's it. We've basically converted the BGP routes into EIGRP routes. Now if we go back to R2, let's test if we can ping 50.0.0.1 now. And then we ping 60.0.0.1. Yep. Let's go to R3. We do a ping 50.0.0.1 and then a ping to 6.0.0.1. There you go. I hope that helped. If you are ready for your CCNA exam, I actually have a video with a walkthrough showing you how to buy the Cisco CCNA safeguard option, which costs $375. If you fail on your first try, you have a safeguard which only costs $75 because each exam is $300. You do not have to pay $300 again in case you failed on your first try.